Okay, let's take a look at the ice cream problem here. A lot of you guys said we end up getting, your calculator has it where you get 30 combinations, and when we go to do this app, we end up getting 21. So why does our calculator say 30, and why does this app say 21? So let's take a look at this. So we have mint chocolate, mint peach, mint vanilla, mint strawberry, mint lemon. Okay, then we're going to do chocolate peach, chocolate vanilla, chocolate strawberry, chocolate lemon. Then we'll do peach vanilla, peach strawberry, peach lemon, vanilla strawberry, vanilla lemon, and strawberry lemon. Okay, now can we do double of the flavors? Let's try it. Mint, mint, chocolate, chocolate, peach, peach, vanilla, vanilla, strawberry, strawberry, lemon, lemon. Okay, so it says I found all of them, right? Okay, what if I try to do, I'm gonna undo something here really quick. What if I were to try to do, let's look at this mint chocolate. What if I did chocolate mint? Let's see what happens. Okay, see how we get an error here? This here, what's called is a combination problem, not a permutation. Permutation is where order does matter, but here, this order here does not matter. So it doesn't matter whether you have mint chocolate or chocolate mint. So this is what's called a combination, okay? So I'm gonna undo this, and I need to go back to my lemon. And here we have 21. So why do we get 21 and not 30? So let's take a look at that. Okay, so if we were to do 6 permutation of 2 flavors, right? We get 6 factorial over 6 minus 2, which is 4 factorial. So that's 6 times 5 times, and if I keep going 4, 3, 2, 1, that's the same thing as 4 factorial over 4 factorial. So that cancels and I get 30, right? So why do I get the 15? Well, if we think this 30, this would include, right? Would include mint and chocolate mint. All right, so we're counting this as twice, all right? When we do the program back here, it's only counting it as once, okay? So what we need to do is we need to divide this off by 2, and then we get 15 that way, all right? So this is what's called combination. So in your calculator, if you want to, instead of finding the P, you want to find NCR, and that is n factorial divided by n minus r factorial times r factorial. So this r factorial divides out all the arrangements, so that way it's only counted as once, okay? So for this guy, this is going to be 6 factorial divided by 6 minus 2, which is 4 factorial, and our r is 2 factorial. So see the difference here and here? See how I have the 2? I'm dividing off that, or that combination of the 2 flavors, right? So this is going to be 6 times 5 times 4 factorial over 4 factorial times 2 factorial. Notice these divide off. This is going to be 30 divided by 2 factorial. 2 factorial is 2 times 1. So 30 divided by 2 is 15. So now we get our 15. Now what about this whole deal of 21? Well, if we have 2 flavors and we choose 2 of them to use, so let's say the mint, right? So this would be like mint, mint, right? This would be 2 factorial over 2 minus 2, which is 0 factorial, times 2 factorial, right? So this is 2 times 1. 0 factorial is always, always 1. It's only one arrangement. You're choosing none of them, so just, it is what it is, just 1 times 2 times 1. So when we do all of this, we end up just with 1, right? So if I do 2 mint, right, I put 2 scoops of mint on the cone, that only counts as 1. Now I do that for the chocolate, I do that for the strawberry, I do that for the lemon. So I'm doing that for all 6 flavors. So this is 6 times 2 choose 2, okay? So this is going to end up being 6 times 1, okay? Because I'm adding this, right? I'm adding 1 for the chocolate, 1 for the lemon, 1 for the vanilla, 1 for the peach. So I have a total of 6 of these, right? So 6 times, right, 6 of these. So 6 times 1 is obviously 6. 6, and then plus the 15, and that is how we get our 21. Okay, so we're going to take a look at that again a little bit later on. That is what is called a combination. So that's how the we get 21 and not 30.